All right, welcome to The Explainer. Today, we're going to trace the incredible journey of artificial intelligence from a simple, almost philosophical question posed decades ago to the powerful technologies that are actively reshaping our world right now. So, what if your doctor was a chatbot? I mean, that's a pretty wild thought, right? But it's not science fiction anymore. As AI takes on roles we once thought were uniquely human, it forces us back to a core question. What does it actually mean for a machine to be intelligent?
To really get where AI is going, we've got to look back, way back. We're talking over 70 years ago to an idea that kicked this whole thing off.
Okay, so picture this. It's 1950, the brilliant Alan Turing comes along and just cuts through all the philosophical noise. He knew that trying to define machine or think was just a dead end. So he came up with a super practical test instead. He called it the imitation game.
And the setup? It's just genius in its simplicity. You've got an interrogator in a room, typing questions, and in another room, hidden away, are a person and a machine. The whole point is for the machine to fool the interrogator into thinking it's the human. For Turing, it wasn't about whether the machine was conscious, it was just about whether it could imitate a human. And that simple idea, it basically set the gold standard for AI for decades.
Okay, but wait. To imitate intelligence, a machine has to learn, right? It can't just be a dumb box. And learning, well, that's the engine driving literally everything we call AI today.
So, when we say AI, what are we actually talking about? At its heart, it's about building systems that do more than just follow a strict set of rules. They have to see the world, figure things out, and, adapt. Kind of like we do.
Easiest way to think about it is like one of those Russian nesting dolls. The biggest doll? That's AI, the whole concept. Pop it open, and inside you've got machine learning. That's where algorithms get smarter with more data. And then inside that, you've got the really complex stuff, deep learning. It uses these crazy multi-layered networks that are kind of inspired by how our own brains are wired.
So, how does a machine actually learn? This breaks it down pretty well. First, you've got supervised learning. Think of yourself as a teacher. You show the AI thousands of pictures of cats that are all labeled cat until it finally gets it and can spot a cat on its own. Then there's unsupervised learning. This is more like just dumping a giant messy box of data on the floor and telling the AI to figure it out. It finds patterns you never even knew were there, like how your streaming service suddenly realizes you have a thing for 80s action movies. And finally, there's reinforcement learning. This is like training a puppy. The AI tries something, and if it's a good move, it gets a treat, a digital reward. Bad move, no treat. That's exactly how AI gets so good at playing complex games.
So all these different ways of learning, they've led to this absolutely massive leap in what AI can do. We're talking about a whole new generation of tools that make the old stuff look like toys.
And to really see how far we've come, let's put old-school expert systems head-to-head with modern AI chatbots. We'll use a pretty high-stakes example, healthcare. An expert system is basically a digital textbook. It's got all the facts programmed in, but it's super rigid. It can't think outside the box. An AI chatbot, on the other hand, it's more like a seasoned doctor who's constantly learning and adapting with every single new case.
So naturally, we had to put them to the test, a direct comparison. And when you look at the cold, hard data, well, the difference isn't just a small step up. It's a complete game changer.
Just look at this. On the left, you've got the performance of that old expert system, steady but stuck. And on the right, the AI chatbot. The gap between them is huge. But let's dig into the specifics of why the AI is just crushing it. And it all starts with speed. First up, response time. The AI chatbot spits out a diagnosis in just 10 seconds. That's more than 4 times faster than the old system. In a real emergency, that's not just a few seconds saved. That could be a lifetime. Next, let's talk adaptability. When you throw new, unfamiliar medical data at it, the AI adapts with 85% accuracy. The old expert system? A measly 20%. It's not even a fair fight. And this might be the most important part. Look at user satisfaction. The doctors and patients who used the chatbot gave it a 90% satisfaction score. So it's not just faster and smarter, it's a tool that people actually like using. But, all this incredible power brings up a really critical new question. Being fast and accurate is great, but as we start handing over more and more responsibility to AI, from our health to driving our cars, we need something more. We need to be able to trust it. Some of the top AI researchers have boiled this down to 4 key things we need to build that trust. First, of course, is capability. It has to actually work. Then usability. It needs to be easy for regular people to interact with. But these next 2 are the really tricky ones. Transparency. We need to be able to understand why it's making the decisions it's making. And directability, which just means we the humans have to stay in the driver's seat, able to steer it where we want it to go.
And that right there, that gets to the absolute heart of the problem. Making sure these systems are consistently truthful, that they're factual. That's still one of the biggest challenges in AI today. I mean, it's one thing to build this incredibly powerful engine. It's another thing entirely to make sure you can trust what comes out of it. So let's shift gears and look to the future. Where is all of this heading? How does this all build towards what a lot of people think is the ultimate and maybe the most controversial goal of AI? You can kind of map out AI's potential journey in 4 big stages. We're already living with the first 2. Stage 1, reactive machines, like IBM's Deep Blue that beat the world chess champion. It can react, but it can't form memories. Stage 2, limited memory. That's stuff like self-driving cars that use past experiences to make decisions. But the next step? Stage 3, theory of mind. That's an AI that can actually understand our intentions, our beliefs. And the final, almost sci-fi peak? Stage 4, self-awareness. An AI that is truly conscious. And just like that, we're right back where we started, with Alan Turing's Ghost. But his question about thinking machines isn't just a fun little game anymore. It's real. It's happening all around us. The big question has totally changed. It's not, can machines think anymore? It's, how are we all going to live together when they do? You know, the search for that answer is pushing the absolute limits of technology and even our own ideas about what intelligence really is. If you found this explainer enlightening and you want to keep up with that journey, make sure you follow for more deep dives into the topics that are shaping our world. Thanks for watching.